I will just shortly tell you the agenda. The presentation is going to be for 15 minutes, followed by demo and then QA session. So let me just brief you on the logistic. We are recording the session, so we will post it on YouTube, and also we will be sending to all the attendees. And for all your question and answers, we have a section QA at the end of the webinar where you can post all your questions and we will try to answer it. Yeah, let me introduce our presenter for today, Amar Kapadia, co-founder CEO, and Shriram Rupanagunta, co-founder and CTO at Aarna Networks. Welcome to both of you. Amar, I will hand it over to you and you can take it forward.
Yes, thanks Priya. So the first question is, are you a GPU as a service AI cloud provider, or you can also call them NVIDIA Cloud Partners or NCPs? If you are, then this is the right webinar for you, and hopefully the content will be insightful and exciting for you. So before we get started, here is what we are hearing from your peers, from other GPU as a service AI cloud providers and NCPs. So static clusters are a great start, but on-demand self-service instances are a must to deal with the huge upcoming inferencing demand. So many times what we see is that GPU as a service providers start their journey with static allocation of GPUs using manual provisioning. And this works great for training customers. If you just have very few but very large training customers that are signing up for long periods of time, then static allocation works great. But once the workload shift more to inferencing and even to other things like fine-tuning or small language model training, then on-demand instances become mandatory. The second thing we hear from everybody is that aging GPUs need to be offered as on-demand to maintain pricing power. So for example, when Blackwell comes out, the training crowd will move to Blackwell and H100s will no longer be as appealing for training customers. So that means they have to be shifted to inferencing customers, and which means they have to be offered on demand. Otherwise, the pricing will crater on those GPUs. The next thing we hear from your peers is that with dynamic usage of GPUs, they need a way to protect themselves against under or over provisioning. So what does that mean? So if the average demand for GPUs for inferencing is 1,000, and the minimum requirement is 200 at the low point of the day in a 24-hour period, and the peak is 2,000, then how many GPUs should you offer? If you offer 200, you will always be fully utilized, but you will have very unhappy customers because 1,800 may not be able to find GPUs when they need them. If you go with 2,000, you have very happy customers, but now your business case is destroyed because most of the time the GPUs will be underutilized. If you go with 1,000, you're sort of neither here nor there. You're somewhat utilized, fully utilized, and your customers are somewhat happy. So this is another big problem that we hear customers talk about. And last but not the least, we hear your peers talking about their users or tenants wanting to do job submission and model serving in addition to just spinning up GPU instances. And by the way, both of these, job submission and model serving, need on-demand instances. And this is actually a win-win because users get more value, and you as an AI cloud provider can charge more for your GPUs if you offer these platform PaaS features as opposed to just IaaS or infrastructure as a service. So on the topic of on-demand instances, we have an ROI analysis, and we have seen through that model that if you offer your unused capacity, just your unused capacity, as on-demand instances, instead of letting it sit idle, that can increase the overall IRR for the entire GPU cloud from around 60% to 112%. By the way, this ROI analysis is available upon request. So if this is something that you would like to see, just send us an email or contact us and we will send it to you. At the end of the presentation, it shows our email addresses and ways to get connected. So before our GPU cloud management software, what is the world before that? So as I mentioned, a lot of GPU as a service providers start their journey with static allocation of the resources using manual workflows for provisioning, monitoring, billing, and scaling. So this is what this diagram shows. It shows hard partitions where GPU resources are statically allocated to different customers. And this works great for training where you have very few customers taking a lot of GPUs for a long time. But now let's say you decide to explore on-demand instances. What are the options? So at this stage, what we see AI cloud providers typically consider are three options. One is to continue to delay on demand. Human nature, you just static allocation works great. You say on demand is a future requirement, let's just delay it. And that works fine if you have a very strong pipeline of training customers. There's nothing wrong with it. The second option people look at is to say, okay, we need to develop a GPU cloud management software or CMS in-house. And this is also great if you have a large development team without any other priorities on the PaaS or SaaS side. So then this is fine. You can take OpenStack or something else and hack it up to make it fit the NCP reference architecture, because OpenStack out of the box does not support the NCP reference architecture. The third is to evaluate third-party ISV products. And there just isn't a large universe of software providers. We happen to be one of them, but we know that it's not a space where there are a lot of options. So with that, I'll talk briefly about the aarna.ml GPU cloud management software on offering from us. So what it shows is the hardware on the left. It can be NVIDIA DGX HGX or any other GPUs or accelerators. Above that is the hardware provisioning layer. It can be a product such as NVIDIA Base Command Manager, or there are many other options also for low-level hardware provisioning. So we can support all of those. And on top of that is our software. The software, let's go from the bottom to the top. The first element is an admin console. So the admin console provides hardware onboarding, tenant creation and management, observability, fault management, etc. Above that is the functionality for the tenants. So the tenants can come and create GPU instances. It can be bare metal, virtual machines, or Kubernetes, container as a service. And these instances are fully isolated. They're fully isolated from a CPU, GPU, Ethernet, InfiniBand, and storage point of view. And together, this admin layer and the tenant functionality layer, we call it the infra management layer. And AI cloud providers can take this layer and convert it into IaaS, or infrastructure as a service. Above that, we have platform features that are useful for the tenant, cloud brokering, where the workload can straddle multiple clouds, automated instance management, where the instance for jobs or models scales automatically. So for models, depending on tokens per second, it can scale out or scale in. It can self-heal in the case of training across multiple clouds. It can auto-stop in the case of jobs. And finally, above that is the workload intent. So what we find again and again is that data scientists don't know what infrastructure they need. They only know, what model they want to run or what job they want to submit. So here we have an intent layer where users or tenants can submit jobs. They can ask models to be served up. And this layer automatically figures out the infrastructure requirements and places the workload onto the right infrastructure, creates the infrastructure and then places it. Of course, jobs or work models are not the only way. The tenant can create explicit GPU instances, bare metal virtual machines or CAS. So that's the product in a nutshell. We offer two broad ways to consume the product. One is licensed software and one is SaaS. So let's go through it. It's a little bit complicated, so I'll walk through it. So you as an AI cloud provider, obviously you provide the hardware. So the NVIDIA reference architecture or equivalent will be provided by you. So GPU, compute, network, storage comes from you. In the licensed software case, we provide the software. We provide the infra management software, platform management. You take that software, you implement it, you operate it, and then above that, sales and marketing, billing, etc., interfacing with the tenant or the user, that's something that you do. So very standard, classic software license model. Then we have SaaS models. So if you want to outsource the sales and marketing and billing to someone like us, or you want to supplement, you can also do sales and marketing, we can also do it. Then we have a SaaS product where we provide the software, of course. And then we provide the user functionality as well in terms of sales and marketing, AI native startups, and then billing, credit, and collections. There is a slight variation on the SaaS as well, and we call that the AI infra marketplace. So there's a slight variation also. If you already have infra management, if you already have the ability to create virtual machines, bare metal instances on demand, then we can just be the marketplace layer, the SaaS layer on top to do sales and marketing, credit collections, billing, and platform management features. So these are the two and a half ways you can consume our software. So call to action. You're saying this is all great, great theoretically. What do we do now? How can we get started? So we have a very concrete offer. If you want on-demand instances, we can get going in less than 1 week. And all you have to do is to provide us with anything over 4 GPUs. You can provide as many as you want. You can provide 512, 1024, but you can provide as few as 4 GPUs. We will implement our SaaS software, so our AI infra marketplace with billing and user management, and we will convert those GPUs into on-demand instances, either bare metal virtual machine or CAS, job submission, model serving. We will also give a custom subdomain, so your domain.aarna.ml. And then the logical question is, what if the demand is more than 4 GPUs? Because 4 is a very small number. Well, we have a solution. Because our AI infra marketplace works with multiple GPU as a service AI cloud providers, we can represent those as yours to the user. So your users, when they run out of the 4 GPUs that you offer, they will get access to unlimited, within reason, put quotes around the unlimited inexpensive GPUs through our marketplace, third-party GPU as a service AI cloud providers. So this is a way where you can offer just 4 GPUs, but your users get an experience of a much larger quantity. So to sum it up, if you contact us and you want to get this going, in less than 1 week, we will provide you on-demand instances. You or your users will get on-demand, fully isolated bare metal VM container GPU instances via self-service interface, serverless, which is job submission and model serving, user management and billing, and capacity trading. So this is the over and under provisioning. So when you run out of GPUs, you can borrow from others. When you have too many GPUs unused, you can sell to others. You could do it in-house. You will need a 15-person team, or you will need to hire some other team, very expensive, and you will need to use additional third-party software, which would cost in the range of 50 plus cents per GPU per hour. Very expensive option. Or you can go with us. Next steps, if this is interesting, contact us. We will get going immediately. You can see the success, and you can keep adding more GPUs. You can keep registering more GPUs with our software. And ultimately, if you want to go to the licensed software and say, this is great, we love your SaaS, it's working fine, but it's now time to take it all in-house. That's perfectly fine. You can just take it in-house through our license software. And just one last slide before we go to the demo. So if you're saying, this is all great, but I still need more time. I need more time to get confidence with on-demand. And is there something less burdensome, less intrusive that we can start with? So yes, we also have professional services where we can get going with your current GPU infrastructure. We have a digital twin offering where we can create a digital twin of your environment. That's to validate your configurations, ensure reference architecture compliance. We can use that digital twin not only for day 0, but for day 1 and day 2. So you can try configurations first on the digital twin before the live production environment. Also things like switch replacement, upgrades, capacity increase, detecting drifts and faults, all can be done on the digital twin, which can dramatically reduce the cost of mistakes on a live production environment. And then if you want to do multi-tenancy manually, but you need help there, taking GPUs back, putting them into the pool once a tenant's term is over, reassigning them to other tenants, then we also offer that. So this is a easy way to get going. When you build confidence, then we can move to the on-demand discussion. I'll at this point hand it over to Sriram, and Sriram walk you through more of the technical details of the demo.
Thanks, Amar. Hello, everyone. Let's go through the demo. So what we're going to show in the demo is the capability to create and isolate multiple tenant instances. As Amar talked about, the software can use a common GPU infrastructure and create multiple tenants on top with a complete isolation. So that's what we're going to show. So the scope of the demo today is first to do a topology discovery. So essentially the entire underlay is automatically discovered. You can also manually onboard it. So both options are there. But in the demo, we'll show the discovery. And then the bare metal allocations to tenants. So these are fully isolated bare metal instances. We also support virtual machines clusters. But in the demo, we'll focus on the bare metal. So along with that, we'll also show how we will do the network isolation. The network isolation involves both the east-west network and the north-south. So both of them are fully isolated for each of the tenants. And last but not the least, the storage isolation. So obviously each tenant will require a storage for running their training jobs or inference, and they have to be fully secure and isolated. So we show that, and then the observability. So there is observability both for the administrator, which is in this case you or your operations team, and the tenant, which is your customers who are logging in and solutions. So both of them will be shown. So this is the demo configuration. As Amar mentioned, we can start with something as low as 4 GPUs, but you can actually go up to a very large configuration. So you can actually go to thousands of GPUs. The software can scale. In the demo, we're going to show with 2 scalable units. So essentially, about 512 GPUs and with some storage nodes. And the configuration has 3 layers of switches. So it's a fairly complex, large configuration, which is as per the NVIDIA reference architecture. So that's what we will show. So the functionality I already mentioned. So we show the day 0 first, which is the topology discovery, and then we create the tenants, we show the dashboards, and then the tenants log in and they allocate the resources, and then we show how the isolation is done and show their dashboards. So it's not a full functionality; it's a small slice of the functionality in the demo. Obviously, the product has a lot more features, such as virtual machines and clusters and so on. But in the demo, that's what we'll focus on. And of course, you can reach out to us if you're interested in knowing more. So maybe you can stop sharing. Okay, so let me stop sharing the demo. Okay. So what you're going to see now is the starting where the administrator logs in, and you can see that the administrator gets a dashboard of the existing resources. So in this demo, we've already discovered the topology. The topology discovery takes some time, a few minutes. So depending on the size of the topology. So there are 19 switches. There are other nodes, and the tenants are 0. So we have not created any tenants yet. So now let's continue. Yeah, so now we can see the infrastructure. So this is the infrastructure that is discovered by the software. So as you can see, this is a fairly complex infrastructure with 3 layers of switches and 64 nodes and some storage nodes and so on. So all the relationship, which ports are connected to what, and all of that is discovered by the software, and it shows you graphically. So you can click on each of those and see which ports are connected where and all the details. So this is essentially the entire inventory and all the relationships, all the ports and which ports are connected to what and so on. So this is essentially for the administrator to debug in case of any problems. So one feature that we have is that we can also do all of this in a digital twin and then create a topology, a kind of a golden template, and then you can actually verify it on the real hardware. So when you actually hook up your entire racks, you can take the golden template and make sure that your connections are as per your intended topology. So you can see the compute nodes that are discovered. So these are all the nodes. There are actually more nodes. So nothing is allocated yet. 64 nodes and 2 storage nodes. So there is the underlying storage network. So we have not created any tenants yet. So now we are going to create. So the tenant creation flow is very straightforward. So you create a tenant and then invite somebody to be the administrator for the tenant. So you go to the user management and invite a user. So you invite them with their email address. So essentially for the first tenant, we are inviting one of the users. So now the user will get an email. So you can go, that user would have got an email, he clicks on a link and then he goes to the registration page. So now the user is registering. So this is the tenant administrator user who is registering. So fairly simple, straightforward steps. So now the user is logging in. So now, until now, we have seen the administrator. So now the persona changes. Right now the user is logging into the same portal. So now the user gets his own dashboard, right? So now what the user is going to do is start allocating, right? So because right now he doesn't have any resources, so he starts allocating. So there are 2 ways the user can allocate. One is a fixed template. So these templates are created by the administrators. So for example, the NCP or a GPU as a service provider creates as many templates as they want, and then assign some cost to each one of them. And these templates are used by the software to allow the users to allocate. And there is also an intent-based template which we'll not cover in the demo, but that's a more advanced feature. So there are 2 ways to do the templates, either virtual machines or bare metal. So now we're going to do the bare metal allocation. So you provide all the OS version, the CUDA version, the number of servers. So you can actually allocate a whole bunch of servers in one shot, right? So you don't have to allocate one server at a time. For example, this tenant is allocating 10 servers together. So he's actually going to get 80 GPUs. And then the pricing information is all displayed. So they can select which option they want, if there are multiple options. So you can see that the nodes are allocated. So they can click on each of those servers and see, all the metrics, all the observability related to that server. So obviously this tenant can only see the servers that are allocated by him, right? By him or her. So here you can see that, they can also see their north-south network and east-west network. For example, for this compute node, these are the IP addresses. These are the switch ports where they're connected to. And then the east-west is also Ethernet. The east-west can also be InfiniBand. So in this demo, we are showing it with Ethernet, but east-west can also be an isolated InfiniBand network. So in that case, we allocate a P key, what's called as a P key in InfiniBand, and provide the isolation for the InfiniBand. And these networks are completely isolated, so no other tenant can access any of their networks. So right now there's no storage allocated to these servers, because the storage allocation is an independent flow. So first you can allocate the compute and GPUs, and then you can allocate a storage and associate that with this with these nodes. So now we're going to do the storage allocation. So you can see that there are multiple options in storage, parallel file system or NFS or S3 storage, and we'll continue to support more. So now the storage is allocated, and that's associated with a compute. So you can see that that storage is allocated for this compute node. So you can see all the details of that node. For example, this compute node has an external storage which is mounted on this mount point with so much of storage, the IP addresses of the storage server, the compute node. So all the details can be seen by the tenant. And network we've already seen. There are north-south and east-west network. So you can see that this tenant has allocated this many nodes, because if you remember, it's allocated 10 nodes. So all of the 10 of them are allocated for this tenant. Now we are logging out and again logging in as an administrator. So this is again a different persona. So now we are back to the administrator. So now you can see that the administrator's dashboard looks different, right? So the tenants have become 10. Actually, in the demo, we saw only one tenant created, but in the background, we have created 9 others for the demo. So there are totally 10 tenants now. There are so many switches, so many nodes, which are all the servers and the storage nodes. So you can see all of the entire inventory and all the tenants from this administrator. So you can see that there are so many tenants that are created. The one that we created in the demo, and then the 9 others that we created in the background. So the admin can go to any of the tenants and see what resources have been allocated. For example, he's looking at tenant 5, and this is all the infrastructure allocated by the tenant. These are the compute nodes. Then they can go into each of these nodes and see what what are its IP addresses and storage. And similarly, there is a virtual machine tab, which currently is not there, but I mean, it's not allocated, but we can also allocate virtual machines. Yeah, so now we've also allocated a bunch of compute nodes for the other tenants, again in the background. This is not as part of the demo, but we have done that in the background. So now you can see that all of the tenants have certain number of servers, 5 or 10 or whatever is the number of servers. So each tenant has a bunch of bare metal nodes. So you can go back and look at the inventory. This screen, of course, you can drag and make them more pretty. So you can see that there are all the nodes have been allocated except the management node. So these two nodes are management nodes. So that's where our software runs. So the rest of them are all the compute nodes which are allocated to the tenants. So you can see which tenant has allocated what compute node, and you can filter based on allocation, availability. So you can see all the network details of each of the tenants, what subnets have been allocated for them, what switch ports are connected to those servers. So pretty much everything that's needed to debug what is this infrastructure. So I think we're coming to the end of the demo. So that's in a nutshell, the functionality of the infrastructure management that Amar showed in the presentation. Now I'll show a quick snapshot of our cloud broker, which is a layer above this infrastructure management, where you can do the job submission and the inferencing and so on. And that also runs as a SaaS. So I'm going to show the SaaS portal related to that. Yeah, so you can see this is how our SaaS portal will look like. So there's a user which is logged in, which is myself. Now they can go allocate GPU instances. They can look at their billing, and then there are settings where they can create their object storage and SSH keys and so on. In the GPU instances, there are two ways you can actually allocate. You can create a GPU instance with a specific GPU flavor. For example, in this case, we are showing a bunch of available GPU resources, and they could be coming from any provider who has a spare capacity and registered with our marketplace. And there is also a way to do that. Instead of just allocating a GPU, you can also do a job submission. Right? So, for example, you can pick something and can give some name to it, and what region you want to run it. So there is also a way where you can give a job details. As I mentioned, there's a job submission and a model survey. And when you go to the job submission, there are more advanced features where you can upload a manual script. And I'm not going to show all of that today, but essentially this is what the marketplace user can use to either to just allocate GPU instances and do whatever they want to do, or they can use more advanced features for job submissions and model serving and so on. So that's pretty much the end of the demo that we wanted to show you. Yeah, back to you, Priya.
Yeah, so we are open for the QA session. We'll just give few seconds. Yeah, so the one question has come. Do you support any GPU fault monitoring and correcting mechanism?
Yes, we do. So the software can also monitor some of the errors, and in some cases, even the ability to make the auto corrections. We do have an MTTR calculator, which actually lets you calculate, what's the response time that's needed for each of those errors, and we can we'll be happy to share it if someone is interested.
Thank you. Okay, I get my next question also. What are the different storage options that you provide?
Yeah, so the standard file storage mechanisms are all supported. So we support NFS, we support parallel file system like cluster. So we also have an ability to mount object storage like S3. So these are the different ways that we can support the storage, and we are actively integrating with other partners for the storage, and the priority being some of the partners announced by NVIDIA. So they are the ones that we are working with to support all of their features, and many of them support all NFS, parallel file system or S3, and we'll be supporting all of them.
Thank you. And yeah, someone is writing. I'll just give a second. Yeah, how do you secure the end client jobs?
So in this case, the client essentially is a tenant, what I explained as a tenant in the demo. So each tenant resources are fully isolated, right? So as I mentioned, these are not soft partitioning. This is not like the way some people do the Kubernetes-based namespace allocation, isolation, and things like that. This is actually hard partitioning. So each tenant gets their own resources all the way from CPU, GPU, memory, storage, network, InfiniBand. Everything is fully isolated. So in that sense, their jobs and their workloads are fully secure from any other user.
Thank you so much. I guess we have to close the webinar because of the time constraint, but there are a few questions which I'm jotting it down, and we will definitely get back. And also we are recording the session, as I have mentioned before. So we will end this webinar. Thank you, Shriram. Thank you, Amar, for the wonderful insight we had today. And thank you everyone for joining. We will come back to you soon with a new topic. Thank you so much. Good night and good day.
Okay,
Thank you.
everyone.
Bye-bye.
Bye.